Today we're going to be talking about how to solve systems of equations using substitution. So last time we discussed how to solve systems of equations using graphing, but today we're going to talk about how to solve systems of equations using substitution. So if we remind ourselves, if we have this system of equations, y minus x equals 3 and y equals negative 4x minus 2, so if we graph these two lines, this is the y minus x equals 3 line, and this is the y equals negative 4 minus 2 line. This intersection right here, if you remember, this is a solution to our systems of equations, and it looks like our solution is negative 1, 2. So if we don't want to graph this, okay, how will we use substitution to solve this? So let's take a look at that. Okay, so here is our system of equations. So what I did was, okay, first I changed the first equation. I added x to both sides, and then I said it was equal to y equals x plus 3. Okay, so the reason why I did that is because at this point of intersection right here, we notice that the x value and the y value are the same for both equations. So when we're substituting, we can think of it as the x's are going to be the same and the y's are going to be the same. So I wanted to switch around the first equation because I wanted to isolate y so that I know that since both of these two y's are the same, that means that these two are also the same. So I can say that x plus 3 equals negative 4x minus 2. And here I have just an equation. So now I can solve this just as I would solve any equation. So what I did was I subtracted 3 from both sides, and then I got x equals negative 4x minus 5. Then I added 4x to both sides, and then I got 5x minus equals negative 5. So that tells me that x is equal to negative 1. So that's what I got when I graphed it. I know the x coordinate of my intersection is negative 1. Okay, but now what are we going to do to figure out what the y coefficient is? So what we can do is we can take one of our equations and plug in x equals 1. So I took the first equation, and then I'm going to plug in x equals 1, and then I get 2 for my y coordinate. Okay, let's see what happens if I plug it into the second equation. The second equation is y equals negative 4x minus 2, and if I plug in negative 1, I get 2 as well. So why is that? So if you remember, this point of intersection, our x and y's are going to be the same for both equations, and that's why we can use substitution. So when we use substitution to solve for one of the coordinates and we want to find the other coordinate, we only have to use one of the equations, not both of them, because they will end up being the same answer. Okay, so our solution here is negative 1, 2, just as we saw when we graphed it. Okay, now for this system of equations. Okay, so here we provided a graph. So if we graphed it, we could easily see that the solution is 2, 5. Let's see if we also get that solution when using substitution. So what I did here was, okay, so since I know that these two y's are the same, I know that since y equals 5x minus 5, I know that this y right here also equals 5x minus 5. So I plug that in. So I rewrote the first equation as so, and it's like 2x minus 5x minus 5 equals negative 1. And then here I have an equation, and I can just solve this as I would with any equation. So I distributed my negative sign, and I got this. And then I combined like terms. I got negative 3x plus 5 equals negative 1. Then I subtracted 5 from both sides. And then I got negative 3x equals negative 6. So that tells me x equals 2, which is what I got here. So I'm going to take one of the equations, and I picked the second equation, and I plugged in 2 for it, and I got y equals 5, which matches my graph. So the solution here is 2, 5. Okay, now let's look at this system of equations. So I don't have a graph here, so how can we use substitution? So again, the x's and the y's are going to be the same at our intersection. So I know that x is going to equal x. So that also tells me that 12y minus 4 is also going to equal 9y plus 7. Okay, so that's my equation here, and I'm going to solve this. So I subtract 9y from both sides, and then I get 3y minus 4 equals 7. Then I'm going to add 4 to both sides, so I get 3y equals 11. And then y is going to equal 11 over 3. So now I'm going to take this and I'm going to plug it into one of the equations. So I chose to plug it into the second equation. And then when I plug it in, I get x equals 33 plus 7. So then x is going to equal 40. So my solution here is 40, 11, 3.